Ladies and gentlemen, welcome to the Big Bear Math channel. We could not be any happier that you've landed in Big Bear Math country here today to get some help with some challenging math problems. And we're going to look at one of the scariest topics in all of math. I don't know if anything else strikes fear in students as much as word problems does. So we're going to focus on solving word problems in terms of one variable tonight. And I really, really hope that when it's all said and done tonight, you feel a lot more confident and you're ready to go to class tomorrow with just your chin held a little bit higher. So we're going to jump right in and really focus on some habits that we want to establish that become routine and automatic. And we want to just make sure that we always start off by taking a deep breath and reading the problem very carefully. I know you can do it. I know you can do it. And we're going to give you the confidence to get that done. Maybe the most important one step here, root habit we want to establish is identifying the unknown. What exactly is it that we don't know? And then assign a variable to it. So for instance, if they're describing a rectangle and we don't know the width, that's the unknown, we're going to assign a variable like X or W to it. Then what we're going to do is we're going to translate the written cues into mathematical notation, okay? And we're going to practice a couple of those here in a second. Number 4, we're going to solve the equation, which I bet is your sweet spot. That's going to be right in your wheelhouse. And then number 5, we're going to practice checking your answer just to verify and indeed make sure it's true. So what are some popular cues that we're going to run into? So if you see the word is, that implies equals, okay? That's a nice one. If you see the word sum or increase, that applies addition. And if you see the word difference or less than, that implies subtraction. Now, words to the wise there, we're going to be very, very careful, and we got to watch the order in which we're subtracting those two terms. All right, so let's jump right in. I'll tell you what, number 1 here is not the easiest one we're going to do tonight. So we're going to say, see that phrase less than? 8 less than a number is 4, okay? So right here, the idea of a number is my unknown. So I'm going to say to myself, let X equal a number, okay? And it's 8 subtracted from that number. So I'm going to say X minus 8 equals, because of the word is, 4. Notice the order right here. It was X minus 8. If I accidentally write 8 minus X, it's going to give me a different answer that won't end up checking when I'm all said and done. Now, right here's your sweet spot. I think we understand that we got to add 8. Whatever I do to one side, I do to the other, and we're going to get X equals 12. So there's my solution. Sometimes your teacher may expect you to put it in some squiggly brackets like that. And now all I'm going to do is I'm going to take that 12 and I'm going to substitute it back into the X. So my check looks like this. 12 minus 8 equals 4. Simplifying 12 minus 8, 4 equals 4. Little smiley face. We've checked it. I think this example is a little easier than the previous one, and I would encourage you to maybe hit the pause button at this point and try solving this one on your own. So we've got a number, which we'll let be X. Increased means we're adding by 12. And then you've got your little equal sign right there. So we're thinking X plus 12 equals 26. Inverse operation here is to subtract 12. And we'll get X equals 14. So we're claiming our solution is going to be a 14. All we want to do now is check it. We'll replace the original X with a 14. And let's see what we got cooking here. Combining 14 and 12 make 26, and that indeed equals 26. We call that a true statement, and it checks. So tonight is all about creating good habits, and these habits are going to carry over as the problems get more challenging year after year. So again, what is the unknown here in this particular question? The unknown is 2 consecutive integers. Now, what in the world are integers? Real quick recap. Integers are those numbers you see on a number line. So anything like -3, -2, -1, 0, 1, 2, 3, etc., in both directions. Now, all of those decimal values in between these integers are not considered integers. But what's guaranteed to be true is that no matter which two consecutive integers you pick, maybe you pick these two, or maybe you pick these two, or maybe you pick these two, the second one is guaranteed to be 1 unit bigger than the previous one. So if we said let x equal the first integer, then we know the next one is guaranteed to be 1 larger. So x plus 1 would be the second integer. And in this particular case, the sum of these two integers is going to be 23. So I'm going to take the first integer, add it to the second integer, and set their sum equal to 23. Now, combining like terms, x plus x makes 2x. From there, I'm going to subtract, let me see if I can fit it in here, subtract 1 from both sides. So these cancel, and you're going to get 2x equals 22. Divide both sides by 2 makes x equals 11. So basically, this is the first of the consecutive integers. The next integer after that would be 12. So here are my two solutions. And again, we could check those by substituting an 11 right here and an 11 right here. And I think we could go ahead and verify that. Now here's a fun word here in the fourth example, and that's the word twice. That implies that we're going to multiply by 2. Now notice they didn't say twice a number, they said twice who? The sum of a number in 5. So if we said let this number be x, we have to take that x, we're going to add 5, there's your sum, and that quantity gets multiplied by 2. Now, if I failed to put those parentheses in there, it totally changes the problem. I'm going to get a totally different answer, and that answer will not check and prove to be correct. And that's going to equal 42. So I'm going to go ahead and distribute the 2 to make 2x plus 10. We're going to subtract 10 from both sides. You get 2x equals 32. It's all about the process. It's all about the habits we're creating. And I think that's going to make, we'll shimmy over here, x equals 16. So our solution, we believe, is 16. All we got to do here is take that 16, substitute it. And you know what? I think I'm going to take the time to do that. Always feels good when you get a check to work. Now, in this case, you want to simplify the 16 plus 5 first to make 21. The color's not really showing up at all, hardly is it? All right. And then 2 multiplied by 21 is going to make 42. So 42 does equal 42. Just a little smiley face. We are good to go. We're going to finish off today's video with a real big bear. And so not only do we have 3 consecutive integers, but catch this word right here. We're looking at consecutive even integers. So a couple of examples that we could potentially end up with solutions is maybe the combination of 4, 6, 8. Or maybe we could end up with 20, 22, 24. Or maybe we get 56, 58, and 60. These are all examples of 3 consecutive even integers. Now, in all of these cases, the second number in the set is how much bigger than the first number? Exactly, it's 2 units bigger. So if we said let x equal the first of those consecutive even integers, then x plus 2 is going to be the second consecutive even integer. And then the third digit, third numeral, is guaranteed to be how much bigger relative to the first number. He's always going to be 4 units bigger than the first number. So now we could say x plus 4 is going to be the third consecutive even integer. So based on those definitions, let's put it all together. We said the sum of these 3 numbers right here is going to add up to 72. So I'm going to take the first one plus the second one plus the third one and set their sum equal to 72. Now what I'm going to do is I'm going to combine like terms. So this x plus this x plus this x makes 3x. And this 2 plus that 4 makes 6. And now we're really off to the races. We're going to subtract 6. That's going to give me 3x equals 66. Divide by 3. Whoops, I want to show that. And you get x equals 22. So if 22 is the first one, let's see. How do we want to do this? I don't know if that's going to show up. Let's try. We'll try red. The first integer is going to be 22. the second integer is 24, the third integer is 26, and just for fun, add those bears together and you will get 72. So there's my solution. So I hope you found something that was helpful, that maybe filled in a little gap, helped you become a little more confident. And I'll tell you what, stop on by for some future videos and we'll continue to tackle some big bears.